Hi everyone, this is lecture video 12, and in this lecture video we will develop chain rule together. Before we start, here is a very summarizing reminding box for you. What we see inside it, you see the limit definition of the first derivative from the previous weeks. You remember that the derivation can be distributed over sums and differences like this. Derivation respects scalar multiplication. You can take C out. And this is the product rule, remember? When you try to take the derivative of product of two functions, you apply this kind of rule. This is quotient rule. And these are the derivation rules. For the power function, you take n down, you subtract 1 from the power. For e to the power x exponential function, the derivative is itself. There are those rules about trigonometric functions. And also, I think this line is kind of new for us. We will be using it in the upcoming lecture. So a to the power x is derivated as itself times ln a, okay? For example, 3 to the power x is derivated itself times ln 3. And this is the derivation rule for ln x. So this is the nice reminding box for you, which summarizes what we have covered so far about the differentiation. Now, let's try to develop chain rule together. Okay. So you know how to take the derivative for cosine function. It is minus sine x, right? You also know how to derive polynomial functions like this. Step by step, you can take the derivatives of power functions. What if now we want to derive the composition of these two functions? And the answer for this derivation problem is given by the rule which is called chain rule, okay? So let's try to write the formal notation for this composition function here. We choose cosine x as the f of x function. Okay, let's name the insider part as the g function, okay? G of x is x cubed plus x. And then if you take the composition of f and g, which is written in this form. So g of x is what? G of x is x cubed plus x. And now you are evaluating f on this expression where f is cosine x, right? That's why instead of x here, you just insert this part and obtain cosine x cubed plus x, sorry. So this function is the composition of f and g, where f is cosine and g is given as x cubed plus x. Now, we want to learn how to derive the composition functions like this. Okay, let's move on. Okay, this is the composition, and the question is how we can take the derivative of the composition. So we are trying to understand how to take this derivative, and the answer is given by the chain rule. So look at this diagram, please. You know, g function takes x and sends it to this image g of x. Let's call this image as u, okay? And then you know what is the image of g of x. This part is the image. Now we call this as u, right? Then this u is mapped to the image of u by f, like that. So f of u is the final image where u is g of x, right? So y function defined as cosine u, then you insert u as this expression to find the composition function. We covered this diagram before. Okay, now here it comes. To take the derivative of such a composition. Okay, and for the composition, you can also use this kind of notation. And this derivative is given by the chain rule as, okay, now we are writing what chain rule is. You start from the most outer function, which is the function f, right? F is the most outer function. You start taking derivative with it. And then you don't do anything about the insider function, but then according to chain rule, you have to multiply with the derivative of this insider function, okay? This is what we call as the chain rule. Let's repeat the rule. So this derivation applies in this way. You start with the most outer function, take its derivative, don't touch the insider function, and then you will have to multiply by the derivative of the insider function. And there's another notation that we use for chain rule, which is called the Leibniz notation, okay? In this notation, we will call f function as y and u as g of x. That's why if you, what is y, then y is f of g of x, where u is denoted by, where g of x is denoted by u. Now, we are trying to take the derivative of f, in other words, the derivative of y with respect to x. So you see y depends on u. That's why you start this rule like dy over du times. Now you move inside, just like we did here, right? You move inside and the insider function is u of x. That's why you multiply it with du dx. And in fact, these are writing the same thing in two different notations because dy over dx is the same as this derivative of this decomposition function is given as dy over du is what? It is in fact the f prime, where u is g of x, times what is the u over dx? You know, u is given by g of x. That's why du over dx, the derivative of u with respect to x, can be rewritten like this. So they are, in fact, writing the same thing in different notations. Now it is time to apply chain rule in a simple example. Let's start with a simple one. Y is given like that, and we want to take the first derivative of the y function. What we will do here, sine is the f function that we have talked about here. This is the outer function, and the insider function is this part. This is g of x. What we do, we start with the most outer function and take the derivative of it. Now I am applying the rule. The most outer function is sine. The derivative of sine is cosine. And then I do what? Don't touch the insider function. Write g of x where we have x squared plus x. Just write it without doing anything about the insider function. Then the rule says what? Then multiply this with the derivative of the insider function. Okay, x squared plus x derivative. This is the derivative of the insider function, derivative of g function, okay? And then you can easily find the derivative of this part. This is a polynomial and the derivative of it like this. So this part corresponds to, now if you want to fit this computation to this rule, this is f prime of g of x, you know? And this part is g prime of x, where g is this insider part. Okay, the rule works like this. Now we can solve the same question by using the Leibniz rule as a second way. Let's write it. Leibniz rule. This is the second notation that you can use. In this notation, you denote the function y as f of u, where u is, okay, f is sine, and we will call this part as u now, x squared plus x. And then dy over dx, that's what we want to find, right? Is given as df over du. You start from the most outer function times you multiply with the derivative of the insider function, which is du over dx. Okay. Okay, u is x squared plus x. What is f of u? Okay, f of u. U is this part, so f is sine u. Now you can easily find f of u, right? It is cosine u times, what is the u over dx? It is 2x plus 1. And then if you want to give the result depending only on x, you can insert this expression for u here. So cosine x squared plus x, this part is u, times 2x plus 1. You see, you find the same thing that we found here. Either you use Leibniz rule or the normal notation. You apply the chain rule like this. Okay, next example. So sine of cosine x. Obviously, this is a composition function, and we want to take the derivative of it. What is the most outer function here? Sine. So we start by taking the derivative of it, okay? Cosine. You never touch inside. You just write the insider function as it is like this. Okay, then what you do? You multiply with the derivative of this insider function. So here you need to multiply with this, which can be computed as minus sine x, okay? So the result goes like cosine of cosine x times minus sine x. So where does this cosine come from? It is in fact the derivative of the most outer function, which is sine x. Okay, let's move on. In this example here, we have sine square x. I think I forgot to write x here. So we want to take the derivative. In this case, what is the most outer function? So y function here can be written as like that. So the most outer function here is taking the second power. So we need to handle this first while taking the derivative, right? Handle this, taking power part first. Because chain rule says what? Start with the most outer function, then keep multiplying with the derivatives of the insider function, right? That's why, first of all, I will take the derivative of the power function, which is taking the square function. So 2 goes down, I never touch the insider part, and then I subtract 1 from the power, so the power is 1 now. And then what should I do? I should keep multiplying with the derivative of the insider function, which is sine x, right? So I need to put this thing here. That's why the result is 2 times sine x times derivative of sine is obviously cosine, like that. Okay, this is the final result for the derivative of this composition function. Okay, let's move on with the more complicated ones. Okay, look at this function. Again, the most outer one is the power function. Let's rewrite this composition function as this. So the most outer function is taking square again. That's why I will start taking derivative by writing 2 downstairs like that, and then I never touch the insider part, cosine x cubed. So 2 goes down as the power, and then I subtract 1 from the power. Now the power is 1. Now I need to multiply with the derivative of this whole thing. Okay, so let's write that down. Sine of cosine of x cubed. So if I find the derivative of this thing and multiply it with this part, I am done. Okay, so let's handle that part. You again apply one more chain rule here. The most outer function now is sine. So the derivative of this thing should start with the derivative of sine, which is cosine. And then you never touch the insider function. Cosine x cubed stays. Then times what? Times. Now you move one step more towards the insider parts. So you need to multiply this expression with the derivative of this insider function. Derivative of cosine is what? Derivative of cos. Okay, let me just write it like this first. You need to multiply with the derivative of this insider function like that. And what is this now? So let's take the derivative of this part. Start with the most outer function. Derivative of cosine is minus sine x cubed times. Now you will multiply with the derivative of this very insider part, which is, okay, derivative of x cubed that. And just this part is derivative like that. So now I am ready to write the final result. It goes like 2 times sine of cosine of x cubed times this cosine of cosine x cubed times minus sine x cubed times 3x squared. This will be the final answer, okay? So let's move on. Okay, next question. This time function given as tangent cube of secant x. So the most outer function here is taking the cubed power. For example, think this function like you are derivating 8 to the power 3. What you do, of course, you take the power down, you subtract 1 from the power, and then you should multiply, according to chain rule, you need to multiply with the derivative of this insider function, whatever it is. Okay, this is what we call as chain rule. Okay, let's start by taking the derivative of cubed power. Okay, so maybe I should use colors. Don't touch the inside. So this is the insider function. We don't change anything about it. We write it as it is because we are dealing with the power function now. The derivative of the power function is like that. Now I will multiply this with the derivative of this insider function, right? So what is that? Let me first write it like this. Now I need to multiply like the derivative of this thing. Okay, you will apply another chain rule here. So what is this? Derivative of tangent. You should start with the most outer one again. Derivative of tangent is secant square. And then you don't change anything about the inside function like this. Then you have to multiply with the derivative of this thing. Okay, and then finally, you can give the derivative rule for secant x, which is secant x times tangent x. So the final result goes like 3 tangent of secant x squared times secant square secant x times this part, secant x tangent x. Okay, this is our final result. No matter how long the question is, as long as you do the derivatives step by step, starting from the most outer function and then moving step by step inside the function, you will eventually find the correct result. Okay, just try to be so careful. Okay, next question. Here, you should recall something. Recall that if you try to derive the exponential function with a power, with another function at the power, the rule is itself times the derivative of the power function, okay? That's why now the first expression can be derived easily by using this rule. It is itself times the derivative of the power function, which is x squared. And similarly for the second one, how it goes, itself times the derivative of the power. Power function looks like this now. Cosine x to the power 5 is the power function, so I need to multiply with the derivative of it, right? Okay, what is the derivative of this thing? Derivative of cosine is minus sine. You don't change anything about the insider function, and then you need to multiply with the derivative of this very insider part, so 5x to the power 4. So the final result goes like, this is the first expression. Second expression itself times the derivative of the power, which is done like that. Okay? So let's move on with the next example. Okay, e to the power something, and this something consists of a product function now. Okay, this function is in this form, e to the power f times g. That's why we need to use, while taking the derivative of the power part, you need to apply product rule, okay? This is while taking derivative of the power, you need to apply product rule because the power consists of a product of two functions. This comes from the product rule. Okay, so let's start. Y prime is itself, right? I never change anything here. Itself times the derivative of the power, whatever you see at the power, you will multiply with the derivative of it, okay? So x cubed plus cosine x to the power pi times x derivative. Itself times the derivative of the power, and this derivative of the power consists of the product of two functions where this is f and where this is g. You know how to derive the products. Okay, so let's try to compute this part now. The derivative of this part goes like derivative of the function f. So this is in fact in the most outer part a power function. So pi goes down. X cubed cosine x to the power pi minus 1. You see, I handled the power part. Then I need to multiply with the derivative of this insider function. So how do you derive the insider function? X cubed is derived as 3x squared minus sine x. Okay, this whole thing corresponds to derivative of f. So times the g function itself plus, now f stays the same, cosine x to the power 5. Now I will take the derivative of the g function. What is it? The derivative, f stays the same, derivative of g. Derivative of x is just 1, right? So it goes like that. This is g, and this is again f, and this is g prime. So we applied product rule for while taking the derivative of the power. That's why the final result goes like that. E to the power x cubed plus cosine x to the power 5 times x times this whole thing corresponding to the product derivative of the power. Okay, this whole thing is what? This is the derivative of the power function. Okay, so let's move on. Here is another nice exercise for us. So some information is given. It is given that the first derivative of the function at x equals, we want to find this at first derivative at x equals 0 if we have this where u is given like that. You see? So this is in fact the composition function. If you insert u with this expression, you will find this. You can try to use quotient rule to take the derivative of f function, and then you can insert x equals 0. But there is also this Leibniz notation, Leibniz rule, to find the derivative of composition functions in this setting. This is more useful. So let's use it. So f depends on u, and u is a function of x. Then we want to find df over dx, derivative of f with respect to x. It goes like df du, the variable of f is in fact u. That's why we are deriving f with respect to u like this, times du over dx. So we start with the most outer function, find its derivative with respect to u, times the derivative of the insider part. This is the Leibniz notation of chain rule. So let's do that. Okay, this is a ratio. This is a ratio. So we need to apply quotient rule here to take the derivative of f with respect to u. Derivative of the numerator is 2 times the denominator, minus numerator stays the same, times the derivative of the denominator over square of the denominator. This part corresponds this, times, okay, you see the expression for you. You can easily derive it with respect to x, right? It is 20x plus 1. So this part corresponds to this. And then what we want to do, we want to find the value of this thing, the first derivative, at x equals 0. So we will insert x equals 0. What happens to u when x equals 0? You can easily find that. What is u when x is 0? Just insert 0 for x here and here, so u becomes 1. That's why we will insert x0 and u1 everywhere to find the result. It goes like 2 times 2 minus 2 times 2 again, and then divided by 4 plus 1 squared. And what we have here, x is 0, that's why we are multiplying. Okay, let's just write it like this. So the result is in fact 0, okay? Maybe I can put a recall here, like how do we take the derivative of quotients? It goes like this, fg prime divided by g squared. Okay, let's move on. This will be the last example of this lecture video. R is given as sine of f of t. We don't know the function ft, but we know the values of it like that. F of 0 is given as pi over 3 and f prime 0 is given as 4. Then what we want to find? We want to find, you see, at the bottom line R depends on t. That's why you can derive it with respect to t. We want to find the value of this thing at t equals 0. So let's find dr over dt first. Please look at the R function. It is a composition function, right? So you need to take this derivative by applying chain rule, obviously. So you start with the most outer function. What is the derivative of sine? It is cosine. So you write the insider function as it is. You don't touch the inside. Then you have to multiply with the derivative of the insider part. Okay, this is the expression if you apply chain rule to take the derivative. Okay, now we want to insert t equals 0 to this expression. You know, f of 0 is given. Okay, let's write it. If t equals 0, what you have on the right side? Cosine of f of 0 times f prime of 0. And this is given as, you see, pi over 3. And this is given as 4. What is cosine pi over 3, by the way? Okay, so we are computing cosine pi over 3 times 4. Now, we need to find this. Cosine pi over 3, you see, this is a very special right triangle. Pi over 3 is 60 degrees, pi over 2, pi over 6 is 30 degrees. So 1, 2, square root 3, you recognize this special right triangle. Cosine of pi over 3 means that this adjacent edge divided by the hypotenuse length. That's why this is 1 over 4. So the result is 2. Okay. This is the last example of this lecture video. I stop here. See you in the next lecture video.